the dignitaries on the dais and dignitaries of the dais and participants of this event, and ladies and gentlemen. A very good morning to all of you, and I am very happy to share some of my thoughts. And it is a very pleasure moment for me of meeting Dr. Prahlada after a long time. We work together. Rather, he is my like a guide and guru when it comes to the development. He is today we talk about a lot about artificial intelligence. If you don't talk about artificial intelligence, you are stupid. But I will tell you something else which AI cannot do. That is intuition. That is one thing which we always relied on Dr. Prahlada's intuitions. Whenever some problem is there, we used to approach him because he was program director for us for most of the programs, whether it was BrahMos. His involvement is in depth, and submarine launched a missile, that also his involvement was so deep. And whenever you approach him with a problem, there will surely be an intuitive solution. So that was our appreciation, and that was our interaction. Anytime he is available, even as when he was director, then also he is so approachable, because you go after 7 p.m., he will be still there. 7 p.m., 8 p.m., whatever time you go to him, he is still there. That's what we used to wonder. Even after Kalam left DRDL, the habit he inculcated in his disciples, it continued. So that's how it rubs off to all of us working for DRDO. Then coming back to my association with FPSI, it is very long, because R&D engineers, so you all are aware, Mr. Arora, he is also like my guide. He was my senior in R&D engineers, worked very hard for hydraulic systems. Some of very pioneering developments in hydraulic systems was done by him, especially in the days of pre-layer tank. Colonel Das and Mr. Arora, they contributed a lot in making this thing, in developing some systems as pioneers. So those were the times when even hydraulic actuators, simple linear actuators, were imported. I remember one incident, I quote that. So once we placed order on a German company for actuator, linear actuator, because that kind of long strokes were not made in India. I need not say it was for a strategic program, but that time we used to give the end user certificate from the lab. So many times I have signed end user certificate without thinking about what is its implication. We did not understand administration at that time. So it did not come. It was denied. So that is when we started pushing industry. So that you have to make these kind of cylinders, and thanks to the extra efforts of Mr. Arora, and then many industries which joined hands, and then we made all those things which were denied to us within the country, especially in fluid power domain. So coming to working on the DRDO projects, some of them very, very challenging. We did Sarvatra, completely hydraulic system, this thing. We did not have a winch, indigenous winch. Today it is available, those kinds of winches are easily available. So there are so many companies making those systems which were not available at that point of time. And then when it came to BrahMos, I was project director for weapon launch system. That is for first time we conceived an idea of mobile autonomous launcher. That means a single vehicle weapon system. A weapon system, single vehicle, everything is there. Right from communication, fire control system, and there is a control cabin, and the hydraulic power system for actuators, and that too with redundancy levels, and there is a captive generator, all compacted in a single vehicle. This you can compare with Prithvi, where it has got number of vehicles, because at that era that was only possible. So that is when Dr. Prahlada helped a lot in we were having dilemma of whether to go for 10 by 10 vehicle, or finally we landed in 12 by 12 vehicle. In fact, we designed the 12 by 12 vehicle, the chassis structure and other thing, because the Tatra original manufacturers, they did not accept that responsibility. So they told, we know the drive system, but we do not know what is coming on the chassis. So chassis, then we told, chassis is a structure for me, for an engineer, for a scientist, nothing is out of bound. We can take up any design as a challenge. There is nothing limits us. So we took up that challenge, we made the chassis, and the complete vehicle chassis was designed by us, the drive and other things was designed by us. So then we made a 12 by 12 vehicle, so that a single vehicle weapon system could be conceived. The specification was the first time, so minus 40 to plus 50. That is, the earlier our specifications used to be minus 20 to plus 55. So this is something was beyond. So plus is not a problem, you can cool it down. But minus is a problem. Minus is you cannot heat the whole hydraulic line. You can heat your tank, but what happens to the frozen oil in the pipelines? That becomes a challenge. And first time we developed that kind of capability and took it to trials in Rajasthan, Thar desert at plus 55. Uh, the the systems worked. If we were asked by army, we have to run it for 24 hours. So 24 hours it went on. But then there were delays of like the permission to launch, what time, what window, and other thing, what time. So there were a lot of like I don't call it as administrative type of tactical decisions to be taken. The army has to give particular window where they want it to be launched, Army and Air Force. So it went on for 3 days. We kept the systems running, right from the thermal conditioning system, the hydraulic, electrical, they were all running continuously for 3 days. We were putting the fuel when the vehicle was running, both for the gensets as well as for the vehicle, because vehicle PTO also is running continuously. So that was the moment, and then we launched successfully BrahMos. Dr. Prahlada was also tolerating that 55-degree temperature. It is impossible to imagine that kind of temperature. So we did that. After that, so we asked, so when will you carry out your user trials? They carry out their user trials. So then they told, this was the user trial, you have shown such a thing, and we don't need to, we have to just formalize and sign the paper, that's all. And then we delivered for the first time the prototype as a system. They told, this is a prototype. Normally they don't accept prototype as a system, deliverable system. We converted all that prototypes in delivered as systems. I think that was an immense contribution. And whether BrahMos was a real, because a lot of great people worked in this program. Dr. Prahlada as program director, and Dr. Pillai as his CEO and MD, giving the administrative support and then the overall guidance, and then Mr. P. Venugopal as the lead project director, leading the whole system. So it was great thing to work. So what we learned and what we achieved was really like Dr. Prahlada mentioned, when we learnt about the use of Akash and BrahMos in the actual war, so there were goosebumps all over the body. There was a real feeling something happening because these are the systems we worked, and then never imagined it will come as a that the country will need the actual use. So many times we felt we developed and it will retire after, say, being ready. Not that it will never go waste. The knowledge always remains with the country and the legacy continues. But then it really gives a great feeling that whatever you have worked on has come to the country's service. So then onwards, because I am a little bit research oriented, academic oriented, spending a lot of time with students as well as young scientists. So we did some research on hydraulic systems also. Like one of my PhD student did. Many things we discovered. See, for hydraulics, number one enemy is contamination. All of you agree. Contamination is the number one enemy because it hits you without giving any warning. That hydraulic engineer, every hydraulic engineer will this thing. You will never know when it will hit you. It is not just by your filter. Filter will keep on filtering without telling it is already coming to the end of its this thing. It will not indicate you. Okay, if there is a rise in pressure, you know that pressure line filter is getting clogged, but you can do nothing in the field. That is the kind of thing it can hit you. So contamination, how do you handle, like BrahMos working in desert, among the desert storm, if it has to work for hours, you have to think ahead, where all it can enter. There, if you go in the desert storm and come back, and then when you take bath, then only you will come to know how many, the sand particles are there in your body. It is this thing. Now I have lost my hair, but at that time, even in between the air follicles, there will be sand particles. So that can kill hydraulics. In fact, that is one of the main complaints of users. It will not work in dusty conditions. It will not. No, hydraulic system only works. Electrical systems fail badly. I have seen myself because all the my friends, that time we used to call my enemies in the electro-hydraulic drives or electrical drives, electrical servo, all those things. Finally, we used to, that is a fight that goes on even today, whether we go for hydraulic actuator or electrical actuator. But when it comes to the big systems, when you need real power, that is when there is no substitution for hydraulics. There is no electrical servo or no electrical drive come to that level. That is ultimate truth. Hydraulic power, many people have this debate. Even very recently also, I did an analysis to say that up to this level, electrical is okay. You are small and it is okay. But beyond this, if you want to go, you have to go for electro-hydraulics, because your servo signals have to come from an electronics controller. So that is carried out lot of system. About contamination, I wanted to just share. It is a transportation problem. Transportation means the particles get transported. They don't come under pressure. They come without any pressure. That is the basic underlying. If you can understand this and incorporate things to remove this problem, the particles getting transported, then your contamination levels can go down and your system will work beautifully even in very, very dusty conditions. So I really thank for giving me an opportunity to share a few of my thoughts. Only thing is what Dr. Prahlada was telling about having a serious research. If you want to carry out research, one very simple idea. If you want to carry out research in this, you can employ academia, no problem. But academia cannot solve your problem. Academia can solve an academic problem. You have to identify, in my problem, what is to be given as academic problem. You have to be very clear in your statement, very clear in your aim. They will not come and solve your industrial problems. They will only solve an academic level theoretical problem where they can do a practical this thing. You can give them some device or something, but your definition of the problem has to be like that. Your general statement of problem will not solve. No research can be carried out. Research can be done very, very specific, pointed. That only is research. Otherwise, you will not get much of output. There is there are a lot of blame on Indian academia. They don't produce much. It is all a lie. If your definition of problem is good, they will solve it. That is the thing. So, thanks to giving me opportunity to share my few thoughts, and wish you all the best for all the participants. Thank you. Jai Hind.